case, if you use your calculator and you do all this work, you do 4 plus 2 square roots of 10 divided by negative 4 and then the separate one over here, you'll get these two answers of negative 2.58 approximately and 0.58. They are decimals that will keep going on, but this is the approximate decimal answer. So this is a special case scenario when you don't get a perfect square in the radical. All right, so you will come across these occasionally, and it's very important you know how to deal with these, which is why breaking down these kinds of non-perfect squares is very important to remember how to do. Now, number 3 goes back to our first kind of example, so let's go ahead and look at that. For number 3, before you can start solving anything, though, you have to make sure this equation is in standard form, which means that it's going to be equal to 0. But it's not, it's equal to 2. So in order to move that 2 and make it equal to 0, I subtract 2 from both sides, and now my equation becomes 2x squared plus 3x minus 2 equals 0. I can now apply the quadratic formula. I would ask that before you look at the rest of the notes, maybe to at least first try to write the equation and substitute, and then verify with the rest of the video to see if you at least substituted incorrectly. So if you want to pause it now, you can. Step 2, after you've went ahead and substituted all your values in, this is what your equation should look like. X equals, remember it's a negative 3 now because b went from positive b to a negative b, in this case a negative 3. You don't need parentheses here necessarily. Plus or minus the square root of the original b squared minus 4 times a times c, which is that negative 2 we had over here. Try to get that in the view there. There we go. Now go ahead and, without looking at the future answer, or to verify, make sure with your calculator you go ahead and do all the work under the radical symbol, and if you do it correctly, you should get a 25 that goes under the radical symbol. You know 25 is a perfect square. The square root of 25 is a 5. So all this work turns our equation into negative 3 plus 5, plus or minus 5 divided by 4. When we go ahead and break this into two pieces, we'll do the addition part first. So our first answer for x will be negative 3 plus 5, which is 2 divided by 4. 2 over 4 simplifies to 1/2. Or if we do the second part, we get x equals negative 3 minus 5, which is negative 8, divided by 4, which gives us a negative 2. So our two answers are x equals negative 2 and positive 1/2. The order doesn't matter so much, but I always tend to go from least to greatest when I have my answers. And now finally, let's go ahead and move on to number 4. Our fourth example down here is an example of one that can't be solved, or a prime example. First, I verified that it's in standard form, which it wasn't, so I subtracted 3x from both sides. All right, I still have no sign that it's a prime equation yet, so I went ahead and continued with my process. I wrote my quadratic formula. I substituted in my values. It is when I did my values here that I realized that all this negative, this b squared minus 4ac, all this right here, gave me a negative 159. We can't simplify a negative underneath the radical symbol because if you have two positives, that won't give you a negative number, and two negatives won't give you a negative number if you multiply them. So there is no number times itself that has the same exact sign that will give you a negative number. So basically, we can't do negative square roots. So if you see a negative number under your square root or underneath your radical symbol, it can't be simplified, and we refer to the equation as prime, and you stop there. There's no solution. All right, so those are your 4 examples. I suggest going back, reviewing, and if you have any questions, feel free to ask your teacher for clarification. Thank you, and good luck on this assignment.